Next example, I'm going to work on question number 12. 12 saying, what's the integral of x square root of 3x squared plus 1 dx. Then for this one, I'm going to set u is inside the square root, 3x squared plus 1, and du will be 6x dx. Now apparently you don't have the 6 in there, but you do have x and the dx. So I'm going to multiply 1/6 from both sides, so that I end up with x dx. That's what I'm looking for. So I can change my question such that it is, or substitute in the two components, the square root of u and this x dx together is 1/6 of du. And that will gives you 1/6. Well, I'm going to rewrite my question as 1/6 u to the 1/2 du. And if I integrate it, that will be 1/6, 2 to the power 3/2 because the integration, the exponent raised by 1, and the 3/2, so it's 2/3 to balance the exponent, plus c. Then in the end, I will get, first of all, I can combine this. That will give you 1 over, this is 2/18, this is 1/9, and the u is 3x squared plus 1, and 3/2 plus c. That will be question number 12. Then question number 14, I have integral x over 5th root of 2x squared plus 5, 2x squared plus 5 dx. And for this one, you want to set u equal to 2x squared plus 5. Then your du is really 4x plus just the 4x, because the derivative of 5 is 0, then dx. Now, you only have x and a dx, so I'm going to change, multiply a 1/4, so I get x and a dx. Then I can do substitution. I will substitute in such that x dx becomes just my x dx 1/4 of my du. And what I have here is 1/, because nothing on the top, 5th root of, now it's u. The whole thing inside the 5th root becomes u. Then rewrite the question. This is u to the power of 1/5, but because it's on the bottom, it's really negative 1/5. And then you have 1/4 in the front and the du. Now when you take the integral for this, that is 1/4. That is 1/4. Then u to the power of, increased by 1, that will be 4/5. And then multiply the reciprocal of 4/5 in front to balance it, and plus c. Then in the end, you can plug it back in this into your u as your final answer. This is the 5/16 and the 2x squared plus 5 to the power of 4/5 and plus c. That will give you the u substitution answer. Then number 18. Now the rest of the questions get more involved with different format. It's number 14, number 16. Number 16, I have integral natural log of 2x over x dx. For this one, derivative of ln 2x is 1/x. So I'm going to set u equals ln of 2x. Now du, here you want to be careful, because normally ln x, the derivative is 1/x, but now you have 1 ln of 2x. That's actually 1/2x, but it's a chain rule multiplied by the 2 dx. It's really just a 1/x dx equal to your du. And that's exactly what happened on the bottom and the dx, so your question becomes integral of u and the du, because this together is your du, and the ln 2x on the top is your u. Therefore, it's u squared, just divided by 2 plus c. And plug back in your u value right here. That will be natural log of 2x. Square it, divided by 2 plus c will be the solution for 16. You want to be careful that when you take a derivative, this is 1/x. That's 2 will cancel because of the chain rule. You still use the chain rule, although this is integration, because for the integral, you have u, you have du. When you take a derivative, that's where you use that rule. Question number 18 is, what is the integral of e to the 2x plus 1 dx. And for this one, I'm going to set u equal to 2x plus 1. Then du equal to, du will be just 2 dx. Let me change another color. Then apparently I don't have a 2 times dx, I only have a single x. Therefore, I'm going to change this such that multiply 1/2, this is just a dx. Okay. Then it changed my question. This is the e to the power of u, and the dx is 1/2 du. And integration of this will be just 1/2. Integration of e to the u is still e to the u, and plus c. And plug this back in. That will be 1/2 e to the 2x plus 1 plus c. Okay. Now question number 20. Question number 20. That's integral 4x e to the x squared minus 1 dx. And similarly, let u be x squared minus 1, du will be 2x dx. And now you have 4x dx. So you only have 2, so I'm going to multiply 2 instead of divided by something in the front previously. Now this is what I have. Then I can change my question so that I have e to the u, 4x dx, 4x dx is 2 du. And integrate that, that will be 2 e to the u plus c. And plug u back in, this will be 2 times e to the x squared plus 1 plus c. Okay, now number 22. 22 is integral e to the power of 1 over x squared divided by x to the third dx. This is actually a pretty interesting question because you would think that maybe I should put u as x to the third because I have x squared. Then I can do substitution because this is my du, this is my dx, this is my u. However, if you said this is u, you still have a pretty complicated question because this is your u, then you still have e to something. Now the way to deal with this is rewrite your question, then you will see maybe it better clear it. So this is e to the power x to negative 2. Multiply x to negative 3 dx. Then you will realize, the e to negative 3 is the derivative of e to negative 2. Well, then you have to adjust the coefficient because decrease by 1 is that. Therefore, I'm going to set u equal to x to negative 2. And du, for this case, will be negative 2, x to the negative 3 dx. So now I have something similar to this. I just don't have negative 2, so I'm going to multiply by a negative 1/2 from both sides. Or I divide by negative 2 from the other side. It will be negative 1/2 du. So that this portion replaced to here, and this is e to the u. Now my question becomes into e to the u and negative 1/2 du for replacing that portion. That will give me still e to the u, multiply negative 1/2 plus c. And you want to plug back in for your u, that will be e to the power of x to the negative 2 plus c. Or you can write the way the question they're asking you is negative 1/2 e to the power of 1 over x squared and plus c as your solution. Okay. I'm going to use I'm going to erase this and have the last 2 questions for the next video for 6.2.